There we go. Do you want to introduce everyone, Cesca?
Yeah. Okay, so hello everyone. Sorry, I'm just going to got it on here. Hi everyone, welcome to the next Microscopy Live. So today we've got Jen, who's the host, me, Cesca, and Dr Kirsty Matthews, who is a specialist in mushrooms. So she will be our expert today and talking through some of the things that we're seeing, as me and Jen are both geologists, so we don't know a huge amount of what we're going to be seeing. But today we're in our new lab. We've got our scanning electron microscope, the Joel IT510, which is one of the new ones. I'm not sure if we've done a microscope around.
We haven't yet, actually. This one's new. Hello.
So how this one works is at the very top, we've got a tungsten filament, which is similar to an old style like filament light bulb, which produces our electron beam, shines through the column, goes through a series of lenses and apertures and interacts with our sample, which is in the sample chamber, which is behind this door here. So we've got our mushrooms all set up and ready to go in that chamber.
Trying to get ourselves balanced.
Just get it.
Oh God. It's a very precarious webcam today. There we go.
Okay, so Jen's going to be driving around today. So
yeah, I don't often get to drive. So as always with Microscopy Live, if you the wrong computer, that's why it's not working. As always with Microscopy Live, if you have any questions, I haven't enabled share screen. See, I've been doing this for so long, you'd think I'd get used to it, and yet every single time I make the same mistakes. Advanced sharing options. You can share. I can share. Over here. Wait, that flow through. There we go. So as always, if you have questions, ask us questions. You can either unmute yourself or you can type it in the chat. We're keeping an eye on it as we go through. If you have questions about electron microscopy, Cesca and I can help with that. And if you have questions about mushrooms, probably Kirsty's the best person to ask. We will do our best. I do have some basic facts about mushrooms, but they are very basic facts. So this is our user interface. So all the typical buttons that you see, this is a little live infrared camera inside the SEM chamber. So you can see our little samples here. So it's 3 mushrooms that we've freeze dried. The rest of them will be my dinner later on today. The most important button is the observation button, and that will turn on the electron beam. And we're going to work in secondary electron mode today. So this is looking at the sample surface rather than any sort of composition analysis. So we're just using the electron to see what shape things are. We've got our accelerating voltage that is currently at 5,000 volts. So actually not very many in the world of electron microscopy. For geology, we often work around 15 to 20,000. Some of the TEMs go up to like 110. It's horrifying.
So why do you not need so many on this one?
Because we're interested in the shape, and there's quite a lot of detail in that. The bigger the voltage you have, the more of an area it affects. So it's really good for looking at compositions because you want to get all those X-rays back out of the sample. But for this, we just want to see what things are where, basically. So the smaller the electrons, or the lower the beam, the smaller the interaction volume, so the more detail that you get. So this microscope does have a few more options. We could take it down to barely a tickle, but that's very, very tiny. So it's kind of a balance between getting a small enough interaction volume to see the detail, but also enough of an interaction volume and enough power to actually get a good signal from it. So at the moment, we zoom all the way out. Here are 3 little mushrooms. So we have a shiitake mushroom, which we're currently on. This is an oyster mushroom, and this is an eringi mushroom. So just going to drive around, see what's there. We've had a quick look, I will confess, just so we know it works, basically. So what I've done is I freeze dried some mushrooms, and we're looking at the gills mostly because they seem like the most interesting bit. There is a little bit of regular mushroom flesh. Yes, it is flesh. Yeah. On those as well. So we freeze dried them, so we've taken all the water out because water doesn't like being electrocuted, and then we've cut them gold to make them nice and conductive. And I'll drive around really. If there's something that you want to see in the audience, let us know, drop us a message, we'll drive over and have a look at it, something that you want to see, and we'll try and find some. This white sort of like ripply bit up here in the top, ignore that, it's just a little bit of charge. So because this is a really 3D sample, getting an even gold coat across it is really hard. So anywhere where the gold coat isn't quite as good or it's fallen off, because I did drop these, you will get like a little buildup of electrons. and it makes it like a little bit sparkly, or it can look like it's moving sometimes. And I guess what you're beginning to see here are the cilia, which are producing your spores. Yeah. And the idea of the gills is that it's just a huge surface area to produce thousands and thousands, billions of spores.
Wow.
Yes. So the aim of their fruiting body, so it's the shortest living bit of the mushroom, the fungus. So most of it occurs below ground, and it will fruit above ground. And the main purpose of it is to disperse the spores. Once it's done its job, it dies. Yeah.
Oh, wow. Pretty cool. Wasn't expecting it to look so kind of like blobby.
Yeah, so any circular blobs you'll see will probably be the spores.
I'm going to give myself 20 minutes before I give up and get Cesca to focus things. I'm really good at flat things, but like, oh, give me something with like texture.
Let's just explain whilst we're doing this. So the important thing about electron microscopy is keeping the beam in focus. So much like you would with a camera, if you want to take a nice photo, you want everything in focus. Benefit of secondary electron imaging is you can actually be a little bit arty with it. So you can focus on things in the background, so you can get like or things in the foreground, and you can actually get some really nice images. This is not one of those nice images. I have done a terrible job.
It looks like that's kind of curled up a bit. So
yeah, that centre bit is fine.
Yeah.
I think the texture makes it more difficult as well because you've got so many dimensions.
Yeah.
So trying to focus a
on.
bit. Yeah. What we can also do is we can take a photo of this. So you just follow like the electron beam by a little blue line in the corner. So that'll save it as a TIFF file, so it gets all the metadata as well. So not only will everyone who registered for the Zoom call get all the data, you'll get all of it as well. As well as some free things. So after taking its image, as always, we do have our prize quiz that we will publish with the booklet that you'll all get access to. Today's prizes are a gel water bottle, as is tradition. And then it's some inadvertently become very stationary themed, which wasn't intentional. We've got the Neoscope sketchbook, which I really like, it's like good quality watercolor paper. The pencil case, which is adorable. We've got gel sticky notes, gel hand sanitizer, which is the best one we've ever come across because it smells nice.
It does smell really good.
Smells really good. It's like a nice citrusy one. Our MicroscopyLIVE stickers. We've got an assortment of lens cloths, as always. We've got the cute Rokumaru one. And we've also got two of the Joel Hokusai prints. So we've got one of the Barpath scenes as well as one of the Mount Fuji scenes. We've finally got a gel webcam cover and a branded Rokumaru pen. These are actually the best free pens I've got from any company. I use them religiously, and am I hoarding a few? Maybe. That's all up for grabs in this quiz, which there'll be a question about some of the data we collect today. Not sure what it is yet. I have no idea what we'll learn.
So when you do that photo, it gives you metadata.
So you get a little text file that goes along with it. It tells you the time, the date, all the conditions that you were using. So if you did want to reconstruct something or take basically the same picture again, you could mimic the actual conditions and everything that you were doing. So it's a good way if you're doing analysis over 2 or more days, you can make sure that you're doing everything consistently. And the images all have this sort of emblazoned on the bottom of them as well. So it keeps track of what you were doing. So if you ever put it in paper, it's just a nice way to show off how you did it. Because there's nothing worse as an electron microscopist as reading somebody else's paper and then saying, and we did electron microscopy, and then having no idea what they did.
The scale bar is also saved onto it.
Yeah. Yep. This little scale bar at the moment is 50 micron, and you've also got the field of view at the bottom there. So this entire picture is just under 300 by 220 microns in size. So pretty tiny. So a shiitake mushroom, which I have some facts about, which is Lentinula edodes, is the Latin name, but the name shiitake is a Japanese name. Of course, it's a mushroom native to East Asia. Let's see if I can focus this. Hey, nice. So the name shiitake actually comes from take, which just means mushroom, but then it refers to the logs that this mushroom particularly likes. So it likes growing on the shi tree, which is, I can never quite say it right, Castanopsis, but it also likes other hardwood deciduous trees. So the name shiitake just means the mushroom that grows on this particular sort of tree. So shiitake has been cultivated for centuries. So the first recorded sort of the first records of cultivation is from 1206 in Song Dynasty China. And it's now probably one of, I think it makes up like a quarter of all commercially grown mushrooms.
It's one of the most widely cultivated.
Yeah.
Isn't it?
You can see why they're quite nice. I enjoy them.
Tasty.
This is kind of more like, so that's the edge of the gills there, into like, I'm going to call it the fleshy bit.
I guess that will be going into the cap, the brewers.
Yeah. So kind of looking at like the underside of it.
Yeah.
The inside of the gills, like different, like kind of outside in terms of the structure. So it kind of looks like it's a bit longer in the middle. Can you see what I mean?
Oh yeah. That's photo take, and then we'll go and find out.
Yeah.
Funny because it's been sort of freeze fractured. So I freeze dried these, and then I hit them with a hammer.
Yeah.
Or it might be like where it's fractured, so it could be like a cross section maybe.
Yeah.
Yeah.
But yeah, I imagine hitting with a hammer is not the most scientific approach, but it did work.
It
It turns out the frame was really solid.
does look like the side on the right is a cross section.
Yeah.
Yeah.
And on that photo finish, we'll go for gander.
Tell us more about your research.
Yeah, so on the website it says you're a molecular ecologist. What is that?
I study small things using DNA technology, basically. So we are trying to explore the role of hallucinogenic substances. So whilst they're being used for lots of medicinal purposes, so
Yeah.
I'm sure people know that psilocybin, which is produced by magic mushrooms, can be used to treat depression, or they're looking into it in clinical trials and things. But before all that, they don't know why these mushrooms produce the compound in wild. So what we're trying to do is work out what is the purpose of this compound. The most obvious answer is insect defense, because these are a great food source, not only for us, but insects in the wild as well.
Yeah.
So the idea is that is it stopping the organisms feeding on them?
Yeah.
And the interesting thing is, so psilocybin is a serotonin antagonist. So it binds to the serotonin receptors and blocks serotonin from binding to it. And so the idea is, yes.
Very interesting.
So not only does it cause these effects, but it affects the central nervous system. So it affects the behaviour of these. So that's what we're trying to look at. So what behaviour is it actually affecting?
Yeah.
Is it the fitness? Is it the feeding? Is it the sleeping? Is it the movement?
Yeah.
Or is it a combination of all? Yeah, we've done some field work on Dartmoor. We've collected magic and non-magic mushrooms. So I'm using a technique called NGS Illumina sequencing, and that's where I'm pulling out the DNA, so the insect DNA that's been associated or within the mushroom caps, to see which insects are associated with magic and non-magic fungi. And so I guess we're predicting to see that there will be a lack of insects associated with magic fungi if our hypothesis is correct.
Yeah.
As always, please just don't go around picking up mushrooms and eating
No.
them. It's a really bad idea.
They are illegal, yes, so no.
Just
don't do
any
that.
mushrooms, some of them will kill you. Just as a note.
Yeah, that's pretty cool. So you're expecting to not find as much insect DNA in
Yeah. And or perhaps we will find a select community. So over time, these insects will evolve and they'll develop mechanisms where they can just resist these toxins or able to degrade them.
Yeah.
So we've got two options that we find.
Yeah, that's really cool. And was this something that you carried on from your PhD?
No, so I did mostly microbial work. So I was interested in microbial fungi. So not only do we have these mushroom-forming fungi, you've got singular celled fungi as well. So you've got these microbes that are in the ground that are really important as saprotropes. So they degrade your organic matter, return it back into the environment, an energy source for other organisms. Yeah. So yeah, most mushrooms are degraders. So they feed on dead and decaying organic matter and return it back to the environment.
I've made the focus bad, no, I can't get it back.
It's okay, I believe in you.
I don't believe in me. When will I learn? As I'm doing this, there's a couple of different ways we can focus a microscope. So you have the typical focus, which I'll just make big. So you see it's out of focus. It's more in focus, it's still out of focus, so I've ruined it. But we can also change the shape of the beam slightly. So we can squish it in the X and Y direction.
That we were looking, we thought was a cross section.
Yeah. In theory, it's hard to tell because I'm doing a terrible job.
It looks like what we're seeing is the basidia, which are producing the spores.
Yeah.
So the longer, danglier looking things. on the bottom half of the image.
Yeah.
No, I'm going to cheat. I'm going to use the autofocus and see what that does.
Yeah.
This is one of our new
Yeah.
microscopes. We've had it for 1 month.
Probably more than that now, I'd say.
Yeah.
3 months.
No, that's not helped. These guys do have a fair bit of automation in them, so this is actually pretty helpful for people like me who never wear their glasses. Where are we?
The one thing that you'll probably see as we're moving around is the image isn't as crisp whilst we're moving, but then when we're staying in one place for a long period of time, we slow the scan speed down. And it basically just slows how fast the electron beam is traveling over across the sample surface.
You see how that image is a little bit blurry, but if I hit the slow button, and you'll see as the image beam comes down, it'll crisp up. It won't look great because it's not in focus yet. But you do get a little bit more detail. Can you try focus? Maybe it's just me.
So these edible mushrooms you've got from the shop.
Yeah. This is microscopy in unnamed supermarket.
So I think so. The idea is, so when they're commercially producing them, they'll harvest them before they generate their spores. And so if we were to get them from a field, maybe you'd see lots more spores.
Okay.
But they look messy, so that's why they don't want to pick them after they've dispersed their spores, for us at least.
Yeah. Very cool. I wonder if different spores would have different shapes as well, or if they're all just kind of
I assume
round.
so.
Yeah.
There's something that pollen is like generically round, but they all do look very different from each other.
Yeah.
I think they do vary. Obviously, I only study one organism at the moment.
Yeah.
But I think typically they're often teardrop shaped. Yeah. Yeah, that even looks like a cross section to me, or like the very tip of the gill.
Yeah.
Isn't it?
Yeah, definitely. It kind of looks like they've been flattened a little
Yeah,
bit,
yeah.
doesn't it?
But that's a huge surface area, so you can see when they produce them billions of spores, that's
Yeah.
how.
That's
That'll do it.
Yeah.
Quite cool though.
Yeah, definitely.
And somehow this is not triggering my fight or flight response that I had with the leaves.
Don't mind this one.
No, this is fine.
Not too bad.
It just looks more like a carpet than anything.
It's
It looks
soft and
like pure
fluffy,
organic.
isn't it?
Yeah.
Soft and fluffy.
It does, yeah. Yeah. I wonder how different it'll look to like oyster mushrooms.
I'll find out. We can have a drive.
Yeah.
Um,
So at the top left.
yes.
Yeah.
So they look very different just holding them.
Yeah.
Be interesting to see if that carries across.
Yeah.
So I guess all your three species here they have gills, but you can also have mushrooms that have pores on the other side. So they're just lots of little holes, and that's what produces the spores.
Yeah.
So you've got your boletes, which can be a tasty one, but you also have very deadly lookalikes. So it's a risky one again. But they're totally different in texture. So it'd be cool to potentially look at them one day as well.
Yeah.
I'll just whack it in course and really go for it.
There we go.
We have two focusing options. We can do it either fine focus or coarse focus. So if, like Jess was finding there, that is actually really hard to tell what's getting better or worse, you can put it in coarse and just sort of shift through the focus quite quickly, and then you can do all the fine details afterwards. That does look different.
It does, doesn't it?
Yeah.
Like still tubes, but a bit more
I don't think-
tangled.
Are we looking at gills here, or are we looking at a different bit?
I think this one is almost entirely gills. It's like the inner surface.
Oh, that is, yeah.
Yeah. It's the inside of
I
it.
did try to get the rest of the mushroom, but then it fell off.
Yeah, it looks like it's got a lot of like again
Lots
two
of fun,
textural differences.
Yeah.
Those mushrooms are another one that like
bit
birds
challenging.
and dying deciduous trees. They're all year round. I think you can find them in this country fair bit.
Very challenging.
Like this is right on the edge.
Yeah.
And again, I did drop these.
Just see if it's all move around.
I guess considering what they're used for in terms of us eating them,
Mm.
they all do different textures, don't they?
Yeah.
And this is often used as a meat substitute.
Yeah.
So I wonder if we could pick up, I guess it would be denser because it
Yeah.
has that tougher texture
Yeah.
to eat, doesn't it?
Yeah. Might go somewhere else.
Those bands that were coming across there were charge effects. So as it's a bit challenging. Things that have a lot of texture and a lot of surface topography, it can be quite hard to get an even coating on them.
Yeah, especially because a lot of these are a bit taller as well, so it
Yeah,
might be that they like shadow a little bit. So this might also be the same, but we'll try it. No, it's actually a bit better.
That central bit seems much broader than the shiitake mushroom did. Like the bits that grow spores seem much shorter.
Yeah. The gills are a little bit wider as well.
Oh, that looks neat on the top.
That's nice.
Yeah.
That's a very dense layer, isn't it? Of spore producing
Yeah.
I
structures.
was hoping to see if I've got any oyster mushroom facts. Spiritus austriatus.
Yep.
Nailed it.
Yeah, we grow them in the lab as well.
Oh,
Yeah, they're really sweet ones for actually. We did we made little Christmas packs last year.
Aw.
People could take them home and they just fruit them.
that's
They're
really
really
nice.
Yeah,
Yeah, growing mushrooms at home seems to play really good top recently.
it has, yeah.
Yeah.
Especially doing it on a sustainable substrate and things as well. It's quite a cheap and easy as well.
Yeah.
Cheap and
And they
cheerful.
look cool.
Yeah. Especially when they're pinning. So I think what I like most about the mushrooms is when they first start to pin and you get the little baby dense plants that grow out.
Yeah.
And we've got time lapses of them actually.
Oh,
cool.
Yeah.
That would be really cool to
Shadow.
see. Yeah.
Yeah, I will do.
When you say pinning, is that when they sort of first grow their first little mushroom?
Yeah, so mushrooms, like I said before, it's the shortest living bit of the actual fungi itself. So most of the mushroom occurs below ground as the mycelium, which can be dormant for hundreds and hundreds of years. And it's huge. So you have the honey fungus, which covers, I think it's like 1,600 footprint pictures.
Is that the one that's
Oregon?
Yeah.
we read that in our bag.
Mushroom, but most of that's below ground, and that's talking about the mycelium. That's the network of the little white fibers. So when they're ready and conditions are optimal, so humid and a bit cooler, you start to get these mycelia that will cause primordia, which are these denser clumps of the mycelia. These then fruit above ground, and that's what produces the mushroom.
Yeah.
So if we get to look at the mushroom caps, that will show us the dense mycelia that are producing their mushrooms.
Oh, cool.
Yeah.
I love sessions like this where I end up learning a lot as well.
Yeah, definitely.
And the other thing you mentioned earlier about them being carnivorous as well.
Yeah.
Yes.
That was very upsetting to read before I'd had a coffee this morning.
So yeah, oyster mushrooms under nutrient deplete conditions, they can actually paralyze insects below ground. So their hyphae can produce enzymes that kill these insects, and then they feed on these insects as an energy source.
Yeah.
I just like I knew none of this. It's so weird. You see mushrooms everywhere, but like
I just accept them as facts. And
Yeah.
actually really no idea what's going on under there.
I think some of the most interesting stories come from the evolution of insects and mushrooms.
yeah. So what about we looking at now?
Yeah, what-
Like, so the gills, these bits of gills. So is this part of the cap maybe?
I think so. 'Cause
So
they're
this
kind
does look like the little filaments and tubes again, doesn't
Yeah.
it?
they're kind of like trumpety shaped. So I think that might be the underside of the cap that's sort of like roll forward and joggle.
Yeah, so this is all the mycelial network, which is, so each of them tubes is one cell thick.
Oh wow.
And so you get the spores, so they produce the spores land on the ground, and then you get, so it is sexual reproduction, but it's not male and female, they call it A and minus, positive and minus. You get compatible hyphae meat, they then produce fertile hyphae and your mycelia, and then that's what begins to pin, and it will produce your mushrooms. So it's only if compatible hyphae meat that you'll actually get mushrooms being formed as well. Yeah.
Your favourite type of mushroom?
To eat oyster mushrooms.
Just generally,
To
emotionally.
research magic mushrooms. In terms of stories, I think because I'm like an evolutionary ecologist, I'm interested in interactions between mushrooms and insects. So I think one of the most interesting one is the cuckoo fungus. So that actually produces a fungi that looks like termite eggs. And so it mimics the termites that its own eggs. So termites are one of the biggest predators of these fungi in their environment. And so actually it just tricks them into thinking they're its own babies.
Genius.
Yeah. So it's a predator-free environment.
I couldn't believe it with the zombie ants as well.
Yeah.
Could you explain that?
So these zombie ants, they're the cordyceps, which in the jungle, the spores are released, they land on the ground where the ants are foraging. They colonize the ants, so they end up inside the ants. It manipulates the ant's behaviour, so it causes the ants to forage to find somewhere that's more humid. And obviously, I read that you said earlier that mushrooms like more humid environments. They crawl up to exactly 25 centimetres, more or less, and it causes the ants. It's the behavioural change.
Yeah.
But how we,
That's
how
so
we
weird.
don't know. But so the ant locks its jaw on the underside of a leaf, so it causes the ant to clench its jaw, get stuck, and then after 3 to 4 days, the mushroom will actually produce out of the head of the ant. So it looks like a pin that's stabbed and stuck these ants at a certain height in the canopy.
I hate that.
Then they sporulate again, produce all their spores that fall to the ground, and it all happens again. So
Yeah.
I've checked the scopes and they can see she's got little reduced windows, like little box in the centre. There's basically just a nice easy way to load a smaller image. So rather than waiting for the whole image to load each time with these big and small changes, it's easy to do it on a little square. So with electron microscopy, we're like trying to focus at a higher magnification what we want to look at, because then as you pull back, the entire image is in focus. So we're 800 times? Nothing in terms of electron microscopy. For us as geologists, quite a lot. But for electron microscopes, nothing at all.
is this still the oyster mushroom?
Yeah, still the oyster mushroom. So this is slanty, it's just like the center of the image is more focused than the bottom and top.
Right, and then the facts about oyster mushrooms. Now, the only one I did find out that I thought was quite cute is that some people call the family of oyster mushrooms oysterlings, which is much friendlier than eating nematodes and turning into a slurry to
Like to have a drive around?
I don't trust myself to focus it anymore, honestly.
Okay.
I failed several times.
Yeah. So the useful thing about this instrument is that when we first put the sample in, you can take an image registration. So this is exactly how the samples look inside the chamber at the moment. So it's just really useful to drive around because you can kind of look and see where you want to go and just double click and it'll take you there, sort of thing.
You'll see it on the little infrared cameras that are whirling across.
Yeah.
It's quite useful.
Okay.
We've got spoiled that recently.
Yeah, we have. There's some instruments that it doesn't do that. This one
I
does.
just get
It
lost.
makes me very happy.
Same family as the oyster mushrooms, the Pleurotus.
Yeah.
I think it's a ringy eye technically. I'm not entirely sure.
Okay.
But you'll see this advertised as well as king oysters or king trumpet mushrooms. They kind of look like they've got like a little cap and then just kind of like a big chunky body.
You definitely couldn't get these mushrooms in the supermarket, 5 or so years ago?
No. So
They're more popular now, aren't they?
yeah. They used to get like nice little selection packs of fun ones.
Yeah.
That's a cool image though, Cesca.
Yeah.
Really nice. That's very different to the other oyster mushroom.
Yeah.
It is arty as well, like you see the shadow on the
Yeah.
leaf.
Yeah.
Yeah.
You quite like secondary electron imaging, so you get to have like a little bit of fun with it.
Yeah.
We've got some needlessly dramatic photos of insects in the past. So we'll take some of these images, we'll take them through Photoshop, we'll colorize them.
Okay, amazing, yeah.
So SEM is always in grayscale because it's electrons and X-rays rather than actual light. The only sort of electron microscopy you can do where you do get visible light is photoluminescence.
Okay.
And depending on the detector that you have, sometimes that will measure color, but mostly it's just a panchromatic. Is there light or is there no light sort of situation?
Okay, yeah.
So if you've ever seen electron microscopy images and they are colourful, because we've done it ourselves.
Yeah.
Unless it's element maps, at which point that is a process that does decide on colours.
I guess, so do you do that or is it frowned upon using Photoshop then?
For marketing purposes, it's fine.
Yeah.
I wouldn't put it in a paper
Okay,
unless
okay,
I was
yeah.
highlighting specific things. So if I had, I'm a geologist, so I don't do it too much anyway,
Yeah,
because there are ways we can put colour in
Imaging.
imaging,
More imaging, yeah.
different elements. But if there was, say I had, I don't know, like some cheese or something with some penicillin in it, I could then go through and want to make it clear, I could like
Highlight the
colorize,
penicillin. Yeah.
just to make it a bit more
That's a
obvious.
useful tool, yeah.
That means I'll have a nice afternoon doing some arty things, which is not a bad way to spend a
It
Friday.
keeps the job varied, doesn't it? So we've got these tubes again, haven't we?
Yeah.
These ones are native to the Mediterranean. And much like shiitake mushrooms, which are named after their association with certain trees, these are also named after their association with roots of the Eryngium campestre, which is a sort of type of sea holly. Apparently that's where it was being named,
Yeah.
where it's found most commonly.
We have a question. So we've got a mushroom question. Do magic mushrooms produce more? I don't know how to say that word.
Psilocybin when
Psilocybin.
stressed. It is part of our project actually to look at gene expression. So at the moment we think it's a constitutive defense, so it's produced all the time. And induced, the opposite is induced defense. So what you're talking about is when the insect attacks it, it's produced in a higher amount. So actually we don't know this yet, but it is part of our project to look at this. So yeah, yeah, it's a very good question though, and obviously it's very unanswered. It's very underexplored, this area of research, because obviously psychedelics were banned in the 70s as well, so it's made it very difficult to research any of these substances. The other hypothesis as well is that when you have the damage to the psilocybin caps, you produce this blue compound, and the bluing compound, well, they also think that could be a induced defense. So the production of this bluing compound is actually deterring the insects. Not that we know what effect it's having, but that is an alternative hypothesis as well. It's all very unknown, yeah. So because of the licensing and the laws and the regulation, it's quite very difficult to do this research, especially in the UK.
Yeah.
Highly controlled, yeah.
I can't tell. But as we've seen, I'm terrible at focusing on anything. It's not a rock. Oh, it's fine to me.
I didn't realise you get bioluminescent mushrooms.
Glow in the dark, yeah, over,
Yeah.
I think over 80 species in the world.
Yeah.
So what I'm saying here, it's quite it's the opposite. So the idea is that the psilocybin is being produced to deter the insects, but the bioluminescent ones are attracting insects. So also insects can be useful for the person. So
Would
they
it be like a taste thing, or because they're luminescing, like
so it's like insect traps. You know, people that are just studying insects, they'll put a Malays trap out, and it'll be a bright sheet, and all the moths and the insects attracted towards it, like, you know, the moonlight.
Yeah.
And if you've got your phone in your bedroom in the dark, all the moths are flying at your phone.
Yeah.
Same thing. And the idea is that they attract the insects in order to aid spore dispersal. So they'll get the spores stuck to them, or they'll feed on them and spread it elsewhere. I'd just like to add as well, I think earlier I said it's a serotonin antagonist. It's a serotonin agonist, so it mimics serotonin. Yeah, just don't want to make sure I put any facts out. But the really cool thing about psilocybin actually is it doesn't kill the insects. The lethal dose of it is huge. Toxicity is low. So what we're interested in is why is it affecting the behaviour and not just killing them? Because obviously if you were defending yourself, the easiest thing to do would just be to kill it. Yeah.
You happy with it now?
Yeah, I am.
Good.
I wasn't happy with it before. I was like, I think it's it's cool seeing like the difference, like seeing it so tubey here and then the tops of them being so like bumpy. Obviously, those are the right words to use. The scientific way.
See, again, I think it's the tubes of the hyphae in the middle again.
So even the gills just outside of an SEM, I just wasn't expecting them to be so tubey or just so like soft looking.
Yeah.
I suppose that electron microscopy is one of what you put in for electron microscopy. It's much more interesting than you think it should be.
It's quite surprising, isn't it?
Yeah.
Well, I've never, until I met you guys last week, I've never seen a mushroom this close. So,
And you're saying the electron microscopy isn't used very often.
no, I hadn't. No, not that I know of. I had a quick search, and there's not too many images, and especially none in magic mushrooms. So I would love to work with you and
Absolutely.
get some cool magic mushroom photos.
Yeah, that'd be really cool.
We quite enjoy taking photos of things.
Yeah.
Because I would like MicroscopyLIVE because we get different samples we wouldn't otherwise do. As much as we love rocks, sometimes it's nice to look at something else.
Yeah, it's really cool to see how it can be applied to so many different things. Like, I mean, I'd not heard of electron microscopy until I did my master's here before I started working here. And it's like since being here and seeing how useful it is for quite a lot of different things.
It's quite a universal tool, isn't it? Help lots of people.
Yeah, definitely. I mean, it's basically everything that isn't a liquid and can
But
fit in there. Yeah, it's pretty good.
It's complex, isn't it?
Yeah, you can actually properly see in the holes now.
Tiny, aren't they?
Yeah, we've got the cell walls of the hyphae made of chitin, which gives it the support. So not that they are plants or they're not closely related to plants at all, but they do have a cell wall, much like a plant does.
Yeah. I read that mushrooms are genetically closer to people than the other plants.
Yeah, so they diverged from plants 9 million years after. No, so you've got your mushrooms diverged from plants 9 million years after. I'm getting this wrong on it.
I don't know.
The divergence of mushrooms from plants was after 9 million years. You have to look at the phylogenetics of it. So you study the DNA. Let me get these facts right. I'm getting all the things. More closely related to animals. That's it. Fungi split from animals 9 million years after plants did. Yeah.
Wow.
So they are similar in the fact that they have these cell walls, but they can't produce their own energy. So they're more like us in that they get their energy externally.
Yeah.
But they don't feed. They get their energy by producing enzymes. So the hyphae produce enzymes that degrade organic matter, and then they absorb that and use it as an energy source. Yeah. I think for years and years and years as well, fungi were very understudied, and they were grouped together with botanists and botany. And so if you went to school or university and you studied botany, you'd have mushrooms were one lecture or a couple of classes or something. But now they are being recognised as their own kingdom, and they're getting a lot more attention. Because they are pretty cool and they're very useful.
It sounds like they've got a lot like ecosystems and stuff as well. So.
You're very good for nutrient recycling as well. And also just like they're a huge food source. There's lots of drugs we get from them. So we've got penicillin, we've got blood pressure medicines and like lowering cholesterol medicines. You've got people starting to produce packaging out of the mycelia. So I know IKEA already use mycelia packaging.
That's really cool.
And also bioremediation as well. So they can feed on plastics and also nuclear waste.
That is really useful.
They can feed on nuclear waste.
Do I want a 3.5 mile like network of radioactive mycelia?
Yeah, so they found them in Chernobyl, where they're feeding this black mold that is feeding actually on the nuclear waste.
Oh, fun.
And they have a melanin which protects them from the ionizing radiation.
Oh, cool.
So yeah, that's why the interest in them is getting more and more and more.
Yeah.
They are very useful organisms.
It's really cool. It's like these tubes are so weird. Looking at them. So these are all hyphae still.
Yep, I believe so, yeah.
Why
It's
does it
all-
have to be hollow? They're hollow?
I believe it's because they're 1 cell thick. So that'll just be the inside of them. Yeah. And when you hear about as well like trees talking to each other, that'll be from underground where you've got the hyphae that are connecting with the tree roots as well. They can deliver nutrients to plants. So you've got some plants that rely on these hyphae as well for the nutrients, so they have this symbiotic relationship. So yeah, the mushroom body is just it's the equivalent to the fruit of a plant. So it's a reproductive organ, and the aim is just to produce and disperse the spores.
That bit might be where I washed it onto the bottom tab. I think that might just be a Jen feature.
Yeah. That's it, like it's been flattened.
That's on me.
Yeah.
We've got about a quarter of an hour left. Would you like to try to open my
Yeah.
I could have a go. I've never done it before.
Yeah,
That's fine.
Go ahead. Here you go.
Oh,
I didn't watch much of what you just said. I'm
It's
looking at
okay.
Yeah. So you can use the mouse to click and drag, or you can use this little joystick thing to move around.
So you can't crash it. It's not going to go up and down. We've turned that
We can
function
move
off.
it like this. as well.
Yeah.
That's a very straight right angle.
Yeah.
Yeah.
So if you double click, I think it is, that'll center that bit. Then you can zoom in using the mouse wheel or the magnification dial on the console. I'm a big fan of the dials personally.
Yeah, me too.
Dials.
Okay.
Yeah.
Yep, so just ramp that up.
It's like you'll be able to see like a proper cross section of
Yeah.
where
And is that will that
feels-
begin to focus over time?
So you can focus using the focus dial, and then if you would
So you
like
can make
to
quite
get,
big changes with that.
Okay.
It'll
Is this,
go a long
I
way.
guess it's equivalent to pause focus?
If you press it down, you'll get a little blue light on
I
top,
see, yeah.
and that does pause focus.
there we go.
Nice. Okay, well, you're better than me.
I think that we're beginning to see spores now here.
I think so.
Yeah, these little round blobs, and I guess it's
Yeah.
more protected there, so
Yeah.
Yeah, to
things
be
have
fair.
stayed intact.
Yeah.
Yeah.
So you can zoom in again. This one will do several 100,000 times magnification.
Okay, so I'm
And we're at
I'm not even
180
there
at the
yet.
moment.
Okay.
So barely even scratching the surface of electron microscopy.
Will that begin to focus?
So you're using the focus dial at the moment. So if you turn the dial so that it focuses more, you can then zoom in using the
Okay,
magnification.
so get focus as
Yeah.
I want it.
Yep, so you get it about right, and then we'll zoom in and
Okay.
then focus again.
There we go.
Oh, nice.
Yeah, it looks like the ball.
Oh,
So
that's
are those
lovely.
balls like spores?
Yeah, I believe so. I imagine that's just a more protected area. So
Yeah.
they haven't,
Yeah,
yeah.
is that right? In
Yeah.
there?
Wow.
Interesting fact about spores is that they travel, I think, 10,000 times faster than a space rocket after launch.
Wow.
Pretty damn fast.
That is
Wow.
fast. As planetary scientists.
Yeah. Directly relevant to
Sorry.
our
Yeah.
interest.
They also produce their own kind of airflow as well to
Okay.
help the expulsion of the spores as well. So some species can do that.
Yeah. Oh, is that what I read somewhere that they make their own wind?
Yeah,
That's how they say
yeah,
it, so
yeah.
that's that. Oh, cool.
So should we focus a bit more?
Yeah, focus a little bit more.
Because out of focus, you want to just bring it back the other way.
Mhm.
Because it's all happening live.
Which bit should I be focusing on here? Because
Depends
obviously
which
it's a
bit you're
different plane.
interested in.
Yeah, whichever bit you'd like to look
I
at.
guess I want to go on this inside bit.
Yeah.
Yep. What we might do is if we hit this RDC button, at the top, that's going to bring up the little reduce window. So now it's only the center bit that's going to move, rather than loading in the whole image.
Okay.
Then it means you can just sort of make big changes without waiting for the whole picture to load in.
Okay.
And you can kind of see how it compares to the focus you had before as well, which is quite
Yeah,
nice. You
yeah.
can see if it's
Yeah.
getting better or worse.
Back into the slow one, should hopefully get quite a dramatic picture. I say that with my lack of focusing skills on a 3D sample.
It's cool how you can see the spores.
Yeah.
It must
That is
be because it's like a
impressive, isn't
protected
it?
thing. Yeah.
Just hit the photo button on there. We'll
Take a
save that
photo of that.
one. We'll probably have a nice sunset and take some other pictures as well.
Yeah. It would be cool to see if, like, in future developments of research into like ecology and mushrooms and everything, if the EM will be more kind of there
Yeah.
and used.
I was just thinking, given how easy matching are to prepare for EM, it's a shame it doesn't happen.
It's just instant results as well.
Yeah.
Yeah.
Which is not what I'm used to in molecular work.
Yeah, and it's non-destructive as well, other than the fact that they're gold coated. And I suppose if you freeze dry them all as well, then it is. But
Who doesn't want a gold coated mushroom?
yeah, exactly.
It's better to.
Yeah, we've got gold coated samples hanging on our Christmas tree at the moment. It's like leaves and stuff.
Oh, the Fungus Christmas MicroscopyLIVE we did last year. So I've got some gold coated cloves, got gold coated orange peel,
Does he?
got
Okay.
a full
Yeah.
little mulling spice set. So that's all live again. So you can drive around somewhere else.
Okay.
You can go
Using the mouse?
entirely up to you. Mouse or
Oh.
joystick.
So I zoom out to get.
So if you zoom out, it'll just move faster.
So as I said, thanks, very interesting topic. I have a pharmaceutical background, so very interesting from that point of view. Thank you for coming.
I guess it's so where you have the shadow, you won't ever be able to get too much focus.
Be difficult.
Yeah, yeah.
Because these are 3D samples and there's quite a lot of 3D topography.
Mhm.
But some things that now we've got like a vague idea of what we're looking at. If we wanted to prepare something to look at those bits, and we could come up with a protocol to do that properly.
Okay, yeah.
Yeah.
Often having just like a quick overview look is quite useful.
Yeah.
Um,
Anything else interesting? So is this it going out of focus?
Yeah, so because that bit's further down.
Okay.
So you can just use the focus dial and you can just bring it back into focus. Keep going.
Keep going that way.
Yeah.
Yeah, all these dials just keep going forever.
There you go.
There
Nice.
That's
Yeah.
easy to use.
Yeah.
Mm.
I think the best way to focus is keep on going until it's out of focus and then go back and then go back to when it's out of focus the other way, and then you find like the sweet spot in the middle.
Yeah.
I'm lost as to where I am now.
Well, if you zoom all the way out.
Zoom all the way out with my fish.
Yeah.
And zoom out.
That's going out, isn't it? Yeah. Oh, here we go.
Yeah. And if you zoom even further out, you'll see that overview image we had at the start as well. So you can use that to find yourself.
Nice. Can you zoom in?
Oh, someone put a little bit of
Cotton
on
hair on now. Cotton or something.
Looks like-
Might be some dust.
Yeah.
yeah, it looks like a very thin thread of cotton, doesn't it?
Yeah. Pete has said, thanks, Jen. Really interesting. Looks like I have been in the dark too long. Best mushroom book I can think of. Got to go to another meeting now. Pete.
Bye, thank you. You think mushroom chestnut?
I love a chestnut mushroom, but I only really like. I haven't been that adventurous with mushrooms. No, I like mushrooms. I just haven't really tried many. So maybe I should branch out.
I think puffball's my favourite, just for fun.
Yeah.
I used to get lots of them in the village I grew up in, and they'd be sort of like them or more.
Oh wow.
Oh, great.
That's really cool.
You can, can't you?
Yeah.
They're making this like steak and things.
Yeah.
Vegetarian steak, but-
Oh, cool.
Yeah, no, just kick them down the hill.
Yeah.
I've stomped them off.
Yeah.
Eating their sword first.
I was
Yeah.
yeah. The environment.
Yeah.
Hmm.
Zoom out with another one.
Yeah,
Yeah,
sounds
entirely
good.
up to you.
I want to see if I can find some inner gills again and see if I can.
Yeah,
get
that's
some
cool.
ones.
Take your pick.
Yeah, actually, they are different, aren't they? Because these were a lot more wavy,
Yeah,
and the other ones were a lot more.
quite rigid.
Yeah.
Yeah.
And what were these ones? I don't
That
remember.
was the oyster mushroom.
Yeah, so these are the more wavy
Yeah.
ones as well, aren't they?
They're
Yeah.
much broader as
Yeah.
well. They also don't hold up to being dropped repeatedly. I do have another piece of it somewhere because it fell off.
Yes, it looks like the only one we have spores on is this bottom one.
Yeah.
That's because it's got that protected little
Yeah.
sort of like U shape at the bottom.
And what species? Is that one again?
The Eringia.
I've never heard about mushrooms.
Neither did I, and I had to Google it several times and then go back to the
Mhm.
back into the box of mushrooms that I bought to find out what it was.
Yeah.
So this is the inner side. So I guess the stipe is on the left, isn't it? Yeah. You see them all kind of going to that left
Yeah.
corner. So I
Yeah.
guess that's where they're joining.
It's the stipe of the stalk.
Yeah. So you've got the cap and the stipe. You'll have a veil as well, which is underneath, which protects the spores. So when you find a new or young mushroom, it will have these really thin threads that are protecting the spores, and then the cap will open. Then eventually the spores will disperse.
Yeah.
And you're left with this little ring as well, often on the top of it. So the top of the stipe, this little ring where the veil broke.
Oh, okay, cool.
And you can often find the colour of the spores as well by looking at the stipe.
Yeah.
So magic mushroom spores are a really nice velvety purple, like a deep purple. But you get various different colours. You get dark black ones, or you get white ones,
Yeah.
coloured ones. So oyster mushrooms produce a really light coloured cream
Yeah.
one. You do this yourself as well. You just stick them, cut the cap off, put it on paper overnight with a moist dish over the top, and look at it in the morning, and you have a
Okay.
really pretty spore print.
That's
Yeah.
really cool.
Yeah.
I didn't know you could do that.
Yeah,
A little graphic picture for us.
Yeah, definitely.
it's nice to see the variation in colour as well.
That edge on the side, that's the top of the cap surface is rolled over.
Okay, it's not. Is it attached to this?
I think so, yeah.
Yeah.
Yeah, so it should be like the outer edge.
I just try if we could find a protected bit to see if we've got any spores, but
Yeah.
This is a messier mushroom, isn't it?
Yeah. Yeah, it looks like the oyster mushrooms hold their structure quite well.
Yeah,
Yeah, they're quite rigid.
Do you reckon that owes them to being a meat substitute? Probably because they're quite,
Yeah, probably.
I think so.
yeah,
Yeah, I
Ridges.
feel like that would make sense.
yeah,
And the small bite tooth is very loose.
yeah.
Yeah.
Less of a typical
Really
mushroom
is that.
texture.
These white bits we're seeing in the gaps, what are
Yeah.
they?
That's charging.
Oh, you can
So
see.
where the gold coat hasn't quite got it all the way in there,
Mhm.
you get a build-up of electrons,
Okay.
and that basically they can't disperse properly.
Mhm.
So the reason we make everything conductive is so that the electrons can land and they can move away, so they don't build up in one area. When charging is really bad, you can actually see the sample moving. So
Okay.
when I first put this in today, it was at 15,000 volts, and you can actually see like the little spore holders. So you can actually like see them moving in areas of
Oh,
charge.
wow, look, see here? We can
Yeah.
see the actual
Yeah.
spores hanging off the little threads.
Oh, that's really cool.
So what meant quite in here, look.
Yeah,
Yeah,
that's really cool.
and nicely arty as well.
Yeah.
Oh, this is nice.
And probably a good one to finish on as well, because we've got 5 minutes left. So if
That's cool.
we
Here we
get this
go.
initialized. Hey.
Got any final questions, Kirsty? Now is the time to ask them.
This must know which way they're going.
It's hard
Yeah,
sometimes.
I think you're going the right way.
Yeah.
The top left is.
So because there's a bit of charge, it's never going to be perfect. Because we'll be warping the signal.
Okay.
A fun little like
Yeah.
alien landscape though.
I guess it's going to be hard to focus because they're all at different
Yeah.
depths,
Yeah.
aren't they? Yeah.
Yeah, definitely.
Yeah, it's not even perfect, but you do get quite a nice little silhouette.
Oh, at the bottom.
I know.
That's nice.
Little cartoon slug.
I guess these spores look a similar size to the other species, don't they?
Yeah.
Am I going to get that any better or no?
Might be a bit of challenge to charging.
Yeah.
Yeah.
If it's something that's interesting for you, we can try and find somewhere else. We might just re-prepare a sample,
Yeah.
see what we can do.
I guess these ones in the middle are ones that are like in their early stages.
Yeah.
And they're just starting to be produced.
So well.
Yeah, the reason why there won't be so many spores here is obviously because they'll harvest them before they produce their spores.
Yeah.
They look less appealing, so they produce if they just express their spores, it just covers all the caps of the mushrooms that'll be growing next to them.
Yeah.
So it doesn't look so great.
Yeah.
Fine to eat, but obviously when they sell things, they want to sell things that look
Quite
nice.
nice. Yeah. Yeah.
Well, that's probably about us done actually.
Yeah, looks like it.
I will stop the share and say bye to everyone.
Mm.
Hey, there we go. So thank you again for coming. And thank you, Kirsty, for joining us.
Yeah, thank you very much.
It's
It's
great
so
to think about
interesting.
electing my hospital for the first time. We've had a good time. I've learned a lot.
I've learned a lot too. I had no idea there was so much of
No, it's never even occurred to me really to look at mushrooms.
I'm
it.
going to definitely be visiting again with all my samples.
Yeah,
Please do.
definitely.
So as always, we will try and get the recording out as soon as possible, as well as the booklet. We normally seem to get them out around sort of like 3-4ish, depending on how long it takes the YouTube video to upload. If you do have any other questions in the meantime, you can drop us emails. We'll do our best to answer everything. And that's kind of
That's
it.
everything, yeah.
Keep an eye out for quiz. Our next one will be at the end of January. Not sure what it will be yet. If you have any ideas or things that you would like to be in Microscopy Live, let us know. I know we want to do something archaeological based. We want to do something else in the marine science world. But beyond that, we're kind of open to ideas.
Yeah, definitely.
As much as we would like to just keep doing meteorites forever, we've done those twice now, so we should probably do something else. So thank you very much for coming, everyone.
Yeah, thank you very
We
much.
will sign off now.